Hello, and welcome to my YouTube channel called Statistics from A to Z, Confusing Concepts Clarified. These videos are based on content from my book of the same name, which is published by Wiley. For more information on the book and these videos, please visit statisticsfromatoz.com. This video is the third in a playlist on variation in populations. The playlist is also planned to include individual videos on variation, variability, dispersion, spread, sums of squares, standard deviation, and standard error. See statisticsfromatoz.com/videos for the latest status of my videos completed and planned. The scope of the book, like most introductory books, includes first and second semester college statistics. That is about statistics in populations. But unlike most other books, my book also includes the statistics in the black belt level for Six Sigma. Six Sigma is a robust and rigorous process control and improvement discipline. So I will also do some videos on variation in processes. Measuring and controlling variation in processes is a big part of improving them. As usual in the book and in these videos, we'll go quickly through a list of keys to understanding, or KTUs, to give you the overall picture on one page. And then we'll go into detailed explanations of each of the keys. For this concept of variance, there are 6 KTUs. The first key to understanding tells us that variance is a measure of variation about the mean. The second KTU gives the formula for the variance of a population or process and the formula for the variance of a sample, and we will also show formulas for variances of random variables. The third key says variance is of limited practical use because it is expressed in units which are squares of the units of the data. The fourth key says the squaring is done to convert negative differences for data values less than the mean into positive numbers so that they don't cancel out the positive differences. The fifth KTU describes 2 common statistical tests which use variances. They are the F-test, which compares the variances from 2 samples, and the chi-square test for the variance, which compares the variance calculated from 1 sample of data to a specified variance. And the sixth and final KTU says equal variance, which can be determined via the F-test or Levene's test, is a requirement for being able to perform a number of inferential statistical analyses. And here, on one page, are the 6 keys to understanding the concept of variation. You may wish to pause the video at this point to read them all together. Okay, now let's begin our detailed explanation of each key to understanding. The first KTU says, variance is a measure of variation about the mean. Variation, is also known as variability, dispersion, and spread. It is one of 3 major categories of measures for describing a distribution or data set. The first category, central tendency, is also known as center, and measures of center include the mean, the mode, and the median. The second category is shape, and it is not used as often as the other 2 categories. And the third category is variation. And variance is one of several measures of variation. There is a separate video in this playlist about variation and the various measures of variation. Let's look at 3 admittedly unusual populations in order to demonstrate a few points. Their individual data values are listed on the slide. And a dot plot for each is shown. The first thing we can say is that they all have the same mean, and that the mean is 0. So mean alone is not sufficient to differentiate these populations. Most often, populations are described by their means and a measure of variation. But which measure should we use? Range is a measure of variation, but it is not useful in this case since the range equals 100 for all three of these very different populations. Ideally, we'd like a measure which tells us the degree of clustering about the mean. So why don't we try the average distance from the mean? We could add up all the data distances and then take the average, but in every case we would get a result of 0, so that won't work. In retrospect, this is not surprising, since the very nature of the mean guarantees that this will happen. Some values will be less than the average, yielding negative values for differences, and some more, yielding positive values for the differences. And these negatives and positives average each other out. To avoid this, we want to measure distances as positives. There are two ways to change negative numbers to positive numbers. One way is to use the absolute value. In fact, there is a measure which uses the absolute value. It is called the mean absolute deviation, but it is not used much. And the second way is to square the numbers. The variance squares the numbers. The reason why is explained in Key to Understanding number 4. KTU number 2 gives us some formulas for the variance. Notice that the symbols for the variance, which are lowercase sigma squared and lowercase s squared, are the squares of the symbols for the standard deviation, which are sigma and s. Note also in the first two bullets that the variance is equal to the sum of squares divided by a degrees of freedom-like term, n or n minus 1. The formula for the population or process divides by uppercase N the population size, but the formula for the sample divides by the sample size, lowercase n minus 1. The effect on the variance of using n minus 1 instead of n is larger for small sample sizes. The n minus 1 adjustment accounts for the fact that small samples will give less accurate estimations of the population or process standard deviation than will larger samples. So variations of small samples will generally be larger than those of larger samples. There are also formulas for the variance of random variables. Random variables take on values due to chance, and they are described by probability functions. KTU number 3 says, variance is of limited practical use because it is expressed in units which are squares of the units of the data. Now that would give us such fantasies as square kilograms, square gallons, or square IQ points. To avoid this, we take the square root of the variance, and that gives us the standard deviation. So why have variances at all? Why not use absolute values? Because squaring has an advantage over absolute value in mathematical calculations. This advantage is primarily due to the Pythagorean theorem of statistics. The variance of x plus y equals the variance of x plus the variance of y, and the variance of x minus y equals the variance of x minus the variance of y. Key to Understanding number 5 talks about the f-test and the chi-square test for the variance, which are two commonly used statistical tests. The f-test compares the variances from two samples. This is analogous to what the two-sample t-test does with means. And the chi-square test for the variance compares the variance from one sample with the variance which we specify. Our specified variance could be a target, a historical value, or anything else. This is analogous to what the one-sample t-test does with means. Another big use for variances is in ANOVA. ANOVA calculates the sum of squares between SSB and sum of squares within SSW. and their means are MSB and MSW. Being means of sums of squares, MSB and MSW are variances. ANOVA divides these two variances to calculate the test statistic F for an F-test. A number of inferential statistical tests require that two data sets have equal variance. These include ANOVA and the two-sample t-test. And residuals in regression must show constant variance for the regression model to be valid. In this graph, we see that the residuals are getting farther from the mean as time progresses. This megaphone shape indicates a lack of constant variance. Okay, that concludes our clarification of the concept of variance. If you liked this video, please remember to press the thumbs up like button on your screen below. I'll be making more videos of some or most of the 60+ concepts in the book if folks like you tell me that more videos are wanted. Please subscribe to this channel to be notified when new videos are uploaded. Also, the website statisticsfromato-z.com has a listing of available and planned videos. Now, videos like this one can be very helpful, but they're not very handy when you want to quickly look up something on the job while studying or during an open book exam. For that, nothing beats a book or an ebook. You can also learn more about those on the website. I'd recommend following my blog at statisticsfromato-z.com/blog. I've got some things there that hopefully you will find interesting, like a Statistics Tip of the Week series, as well as posts showing that you are not alone if you are confused by statistics. I'll also be posting on the Facebook page Statistics from A to Z and on Twitter as @StatsA to Z.